Okay, let's talk about the CQRS. Uh, Nowadays, you can say whenever we are designing the system that's for the bigger or enterprise application for the larger audience and where applications my uses are very high. So in those scenario, we have to think how can meet the customer performance or application performance as quick as possible. So these are the one of the architectural patterns CQRS which help us to design a systems in a very different manner, not just a traditional way. And this, if we are designing such systems, we can get the benefits of this CQRS. CQRS, that means the command query responsibility segregation. So as a mm, description mentioned, segregation, they are separating the commands and query. These are the two things. Generally, any applications, the customers or any clients can get a two kind of a request. One is the command. Command is hey, they give command hey, add, update, delete. They want to generate some data. Okay, our applications are responsibility. Hey, whatever the information system they let's put them, let's store them. Later part, customer say, hey, query, I want to ask, hey, give my data. I want to get my data again. After some time, after day, after some different condition, different filter, you have to store and we have to again read data and again give. So generally, any application where some data are generated by the clients are the events and we have to store and later parts surely those data for analysis for uses for the purpose clients are demanding those data. Hey, I need those data. So our objective, this customers response times for my because data is generated by the maybe limited time, but data, same data, old data, many times customer or admin or a specific purpose, we can view, we can get. So this CQRS architectural patterns suggest the different way to implement to design our application, how our applications our system can handle the command, that means the write operation, store operations, and how my systems operate designs for the get our query our questions kind of a request from the client point of view. So let's talk about this CQRS architectural design patterns that help us to improve my application performance. Okay. So as we discuss, CQRS is an architectural patterns that separate the responsibility of handling commands or writes and queries are read in the system. So generally, whenever we have a system, the same system is responsible to write data, a same system is responsible to read data. So generally, by default, whenever we are designing system, always thinking customer send data, we store. And later part, customer ask, hey, I need data. We already store data. And from those data, we read and returns. But this is general basics concept. The same way we designs lots of system. But this pattern say it's not possible. You can separate out these two kind of two natures of the request, one for the writing and one for the reading. So here say decouple the domain logic for handling the logic from the handling to the query. There are two commands. One is the commands that write data, one is the query to get data. So is it not possible these two have the separate system, separate domain logic, they can handle independently. So it's if we design such system where our data handling means key writing, storing is the separate subsystem is responsible, and our data reading, data responding should be the separate business logic handler. So this pattern say just decouple these two write and read operation so that our system become more flexible, scalable, and maintainable. So this CQRS design pattern help us to improve the application performance. Is it sure? But also may help us to design system that is more greater flexibility with scalability and maintainability. So let's talk more about this CQRS patterns. So these are the basic concept. Let's understand. So in the as we discuss, our objective in this CQRS patterns, we have to decouple our write system and we have to decouple to the read system. If these are the two independent, hey, any write operation go to the here, okay, any read operation go to the here. But question is that if data is written here, the read operation again go to the read data here somehow. That means again you are depend upon the only one source of data. So how to decouple it? So this is the techniques. Hey, CQRS pattern say, hey, you can decouple this both operation in the separate system so that read and write can happen independently. In this way, our applications get queries are much faster than the previous with a coupled system. So this CQRS pattern say, hey, just decouple, break your system into the subsystem, one for the write operation, one for the read operation or get query. Okay, so in this CQRS design pattern, two concepts. One is the command, one is the query. So let's talk commands. So command request represent a request to perform an action that change the state of your system. So whatever my system, any command or request come, that means they are going to change my system. They are going to adding data, updating data, removing data, deleting data, something that's going to change my application. Those represent as a command. Any request come that change my application state, that is known as a command. The command typically handled by the command handler. So any request come, that request going to the change something, so who will handle the changes? So we can create one command handler. So in this architecture pattern, there is one command handler. Command handler is responsible to handle all those requests that are responsible to change the application states. So command handler is responsible to handling commands, validating them, executing them, corresponding to the business logics, whatever it is. So generally, these patterns, we have a commands that means the any user request, client request that's come to my system, and my command handler is responsible to validate them, to handle the command, and accordingly they can update my application state. And the next is the query parts. Query also represent a request to retrieve the data from the system. Now the query means I want the data of 1 day or 2 day or some of the data, any kind of request. So typically the query is also handled by the query handler. So in this patterns, we say, hey, there is a one command handler that responsible to handle all the command requests. One is the query handler. Query handler is responsible to returning requested data. So query handler is responsible to handling query and returning the requested data. And there are two more terminology, the model and event sourcing. So generally, CQRS is implemented on the basis of event sourcing. Event sourcing already we discussed. Event sourcing is a concept where application going to store all the events that are changing my application states. And for those events, we make one proper data structure to optimize query, update, response command. So these are the event sourcing is the you can say the concept through which these CQRS patterns are easily implemented. But this concept is the very help to implement this CQRS event sourcing. The event sourcing is just like a event source database that's responsible to store all the historical application state change. All the commands come to change my application states that are stored in the event sourcing event source database. So these are the basics architectural point of view. So whatever the client here, client maybe our user, maybe application, microservices, third party, anyone. So whenever they are using maybe front-end applications or maybe direct gRPC API call, REST API call, FTP call, HTTP call, anyone. Finally, our system is taken. One is the command handler and one is the query handler. So these two components we have to build. One for the command handler that's responsible to receive all those requests that are designated to change my application state. That means they are going to add new row or update row or delete row or something, change the data, update the data. So these are the database write operations are taken care by maybe file system database in this command handler. And second system is your query handler. Query handler is only responsible to response data that's user requested. So question is that this query handler from where they are going to read data. They are not going to read data from your write database, because write database maybe continuous events are generating, continuous data is going to write. Maybe this is a very loaded, very heavy loaded, and you are going to perform high read, your application performance going to the slow. That this CQRS pattern say, hey, we are going to decouple the write and read operations so that our application performance can improve. So here say, hey, you don't go talk to the right database. Even you have your separate read database where only your intention go and read data from the here. The question is that the right data written in the right database. So how we are going to data read from read database? So again here the concept come syncing your data to this database. If you are sync directly here, that is also problem. You directly your database is vulnerable. So in this case, you are going to concept the here event bus. Here event base. Whatever data here going to return in the same times, the same events are going to write in the event bus, and our event bus is responsible to going to write in the read data. So these are the asynchronously way where your write data are going to available in the read database as a concept of eventual consistency. What do you mean by eventual consistency? Might be a particular x times, particular a time the data is written in this here, and the same data are written to the event bus, and event bus going to write data in the read. So this delay fraction of times might be take. So means this database, read database, is going to consistent with the right database. Eventually, that means it will take some couple of microsecond time to sync data. So this is due to say, hey, the write and reads can separate if both have a consistent data. So that now our query handlers just go read data from the read database and response to the customer. And now read handler know, hey, we have already up to date data. Little bit delay happen, but the where little bit minor fractions of microsecond delay are allowable in those scenarios, CQRS patterns we can use. The system you are designing where you are no any kind of data inconsistency, zero times or zero kind of a zero no real time actual real time consistency want like a financial domain transaction domain you don't kind of violate the consistency. You need a high level of consistency. In those scenario might be CQRS pattern not help us, because where your data consistency is major requirement, but lots of applications where consistency little bit delay can be manageable, like video calling, or might be your online gaming, might be your live streaming, might be video streaming, might be singing play. So lots of places where the high level of consistency might be compromised little bit, and eventually consistency ensuring that your data will be available, surely available, minor fraction of times during the which our event bus are processed and data is stored in your read database. This is the fractions of times the delay happen. Okay, so that is the major architectures of the CQRS patterns. CQRS patterns say, hey, just decouple your write operation with a command handler in read operation with a query handler. Query handler is responsible to read data from the read database and response, and command handler one responsible to write data in the write database, and the same time they can also write data in the event source, but so that those events are properly synced to the read database. So as I'm talking, there are lots of use cases where CQRS kind of play a role. Okay, so generally, whatever the complex business logic, also CQRS is well suited for the system with a complex business logic where the commands and query handling require the different approach. Maybe high performance systems where you want to our data read so available so quickly, so fastly, then CQRS help us to improve the performance by allowing optimize read and write path differently. And even they are mentioned the scalability. CQRS help us to design a system that's scalable in the different component, because we have a different handler component, different query, and they are independently can be handled scale. And these patterns also meet the real-time system design. Somewhere you want to response as real as fast. The CQRS help us to design the real-time systems where the commands and queries need to be handled with a very low latency, because we have to deploy the queries handler near to the customer, near to the client, so that latency can be reduced and write can go to the different way. Okay, so lots of benefits use cases here. So these are the couple of benefits which this CQRS pattern help us, like improved performance. There's a major benefits of the application where your application highly read operations are so high, then CQRS pattern help us to optimize and read write path differently, and overall your system performance is going to increase. And even you can increase the scalability because your applications are decoupled in the write module, write handler, read handler, both independently can scale, independently can be destroyed. And you even the different database available, there is no challenges with the scaling, and even easier to maintain because you are decoupling the particular engineer come, hey, want to understand the writing the process, they only look the command handler where the writing process, updating database, and the some are the get query, very complex query, very lots of complex get operations, those are easily went. If your code base is very simple, modular, easily can be update, easily can maintain, easily can be modified. So in future some query need to modify, so our system engineer have a very specific module they are going to touch and modify, and only specific module they are going to test. So over I can say this provide the better flexibility in future. Hey, someone say I want to some different kind of query, different kind of change required, different format, different output want, so we can just go to the change our query handler modules, not the entire read and write operation, because both are now this design pattern say, this architecture pattern say, hey, these are the decoupled from the write and read in the separate module, separate systems. There's lots of benefits we have. We cannot cover each and everything, but still, these CQRS patterns, if you are going to implement, lots of challenges and limitations also you should aware. These are the some couple of them, but I cannot list. Whenever you are going to implement this CQRS patterns, you add the one more complexity, because before your system is very simple, right? Request come write and request come read and write happen in the same system, singular module. That's very simple, simple to implement, simple to debug. But whenever you integrate these CQRS patterns, your designs become a little bit complex. So we have to properly maintain the component and infrastructure deployment accordingly this complexity. And here we have to again introduce the event sourcing, because now you have to manage, implement event sourcing concept. You have to maintain each and every events that are are the command handler retains in the event source, so that those events are properly replicated to the corresponding read database. So here we have to implement event sourcing can add the complexity and require the significant change in existing system as well as, and might be some time here I previously discussed about the consistency. Here CQRS going to commit, I am going to support the eventual consistency. That means our data will be consistent but little bit delay. So ensuring consistency between the command and query models be the challenging if you are dealing application where the your high level of consistency required, like a financial, like a transactional, like where the financial transaction going on. So similarly, here the query complexity, handling complex query can be more difficult in the CQRS patterns. So lots of challenges and limitations this CQRS pattern had. We as a system designer engineer, our responsibility, we have to keep in our minds while implementing CQRS in our systems. Let's talk couple of technology we have available that help us to implement CQRS patterns in my application. So if you are building the Java application, this is the one of a popular framework, Exxon framework available that's help us. You can build the CQRS based systems. If you're a .NET based application, you can use N service bus that building the distributed system on the basis of CQRS patterns. Here we have to also need to select your event store, proper event store database that especially designs to storing events in the event source system. Even for event sourcing, for event was highly nowadays use the Kafka, Apache Kafka to sync data, make ensure the eventual consistency between the write database to the read database. So for the distributed streaming platform, that can be use the Apache Kafka as an event source in the CQRS systems. And even you can use the Redis as well as in-memory data store for the caching and storing the fast application, improve the performance. And if we talk lots of applications nowadays already in the industries, they are implemented on the basis of CQRS pattern. This is not very new pattern. Lots of applications nowadays are using. If you talk about the Amazon itself, this e-commerce platform, any e-commerce platform generally new. There are some season where the lots of read happen. So generally read and write requests must be go in the different handler, different services you can say, so that this architecture can handle high volume of the command and even high volume of the query, because now both have a different services, different modules. Even you can talk about the Netflix, the recommendations engines are used the CQRS based architectures where they manage handle lots kind of a query and updates in the same fashion. When talk about the LinkedIn messaging subsystems are used by the CQRS systems. This architecture handle high volume of the message and even as a updating the messages, updating the new feeds, updating the some new events in the systems. Even you can talk about the GitHub notification subsystems. Also use the CQRS to handle the high volume of notification to update. Hey, lots of GitHub notification server, you receive the lots of notification. Hey, something commit happened, something modify happened, something change happened, some reviewer have a change. So lots of notification system are nowadays. Now you can say CQRS pattern that help us. Even you can say Akamai is the content delivery networks. This content delivery networks also use the CQRS based architecture to handle the high volumes of the request and user update. So you can say in the industries, lots of applications, bigger industries where the read operation is very very high and the same time write operation also. So we have to decouple, we have to segregate write operation in a different subsystem, some microservice, and read is a separate microservice so that the optimal system performance can be achieved from these CQRS based architectures. So these are lots of reference architecture you have available. Just go read out, and they help us to understand how the CQRS patterns implement. Lots of CQRS places may be designed that like systems where the you want to decouple your system in the different module, right? Different. So in this way, we have to read out the details and event sourcing, everything available, and just your different kind of systems are integrated, different database. Here you can say loose coupling, also read write in the different master slave, different kind of architectures available. Just read out. Even the if you're talking about the any open source, there also support how CQRS patterns you can implement. If you talk about the Amazon also supports CQRS patterns, how to the write APIs go to the write database, read API go to the read database, and both write data and the read data are synced with the event sourcing. They are generate event, and events are going to the sync to the different event read database. So you can say these are different architectures. Whenever any request come, our routers going to try this is the update command, go to the update microservices or reads deployment microservices, and they are find the whatever the domain model, data model they are going to use Amazon DynamoDB, and here he can use the Lambda functions that going to make as an event source and syncing data to maybe different database, maybe here Amazon Aurora, where the data transfer object to the your data systems. So you can say different designs available, and even all the nowadays cloud provider offering. If you want to deploy your application in the CQRS pattern, first you build your application like a read and writing the separate services, and all the separate services. Notice here, these are the separate services. They can scale independently, they have a flexible, if something modified change here, easily maintainable, here easily maintainable. So this CQRS pattern help us your system are easily come under the scalability modes, and your system is easily to maintain as well as. Okay, so these kind of if you decouple your write operations and read operations separately, and later part using the event sourcing concept, you have to sync your data, write data to the read data. In this way you can meet your application one level of performance which you want. Okay, so these are the basics about the CQRS patterns, CQRS architectural patterns. These patterns simply say, hey, you have to decouple your systems from the read and write to the separate, so that you independently you can scale the system, independently you can maintain the system, and in this way you can receive your application faster, because your application read uh, requests are faster, write requests are faster. Overall your application performance going to improve if you are implementing CQRS patterns in your system. Hope this information is helpful for you. Thank you.